All right, so last week I did like a really brief introduction on distribution. It was one of those where it's just like, oh, why would we do this? It seems pointless because I did it with basic numbers. But now we're going to do it with variables so that we can see why it's actually really useful and we use it a lot. Okay, so, and we're also going to go over the formula for area, because this is like a basic formula that everyone should know. If you ever do renovations or try and fix up your house or whatever, you're going to use area a lot. Okay, it's a really big thing if you're a contractor or construction worker, things like that. Okay, so let's say you have a room or a house or whatever. We're going to make it really simple. Okay, so maybe it's like 5 meters by 4 meters. Okay, and maybe I want to add an expansion to my house. Right, I want to make it 7 meters longer. Okay, or it can be feet. I mean, if it's feet, it's like it's a closet basically. And maybe I'm widening my closet. I don't know, whatever. Right? Units don't really matter right now. We're just learning. Right, so let's figure out first the area of this one. So area is equal to length times width. Or you might see it as length times width. Right, so the area 1 is going to equal to 5 times 4. These are perfect, rectangles. I should say area of a rectangle. It's different if you've got a triangle or something like that. We're just learning the basic area of rectangles. Right? If you do geometry, you'll learn the areas of all different kinds of shapes. But for algebra, this is good enough. Okay, so area 1 is equal to 5 times 4. So area 1 is equal to 20. Okay, so we're going to call this little square area 2. Right, I'm just extending it so it's still 5 on this end. I added 7 feet there, so this time it's 5 times 7. Okay, so area 2 is equal to 35. Let's say I want to figure out now, like I had my old area, we'll just make it a closet to make it easy. Make it 5 feet by 4 feet. And then I wanted to make my closet wider so I could fit more things. So I'm adding 7 feet. Well, that would be a huge closet. Okay, doesn't matter. We're making a closet that's really big. Right, what's going to be the total area of my new closet? It's going to equal to 20 plus 35. It's going to equal to 55 square feet, or feet squared, whatever. All right, so there's another way we can do this if you think of the distribution method. All right, here's my expansion. So if you remember, let's just say I want to add these together. Oh, sorry. So I'm just like getting the total length. Instead of doing it separately, I'm going to be like, let's just add the total length together and multiply it by 5. 7 plus 4 is 11. We get 55. And actually up here I want to rewrite, right, because that gives us those. So if we look here, this is the total area. 5 times 4 plus 7 is equal to 5 times 4 plus 5 times 7. Right, we did this 2 ways. We did it the first way where with 2 separate areas and we added them together. And the second way where we just added together one whole side and we got the same thing either way. Right, so if you notice this, and we did kind of go over this last time, this is distribution, right? It's the same thing. We got 55 no matter what. 5 times 4 plus 5 times 7, and we get 55 on each side. Okay, so that's distribution. Again, I'm showing it in like an area form, introducing the area formula. So why do we need to know distribution? Right, because there comes a point where you can no longer add what's in those parentheses, right? You're trying to do PEMDAS, you have a problem, say you have this problem right here, and actually I'm going to take away the last part, make it simple first. You're trying to simplify it, you're trying to make it a nice condensed little formula, but I can't add x plus 5. Why? Because I don't know what x is yet, right? X is a number, but I don't know the number. It's unknown. So I can't add this together. Instead, what I can do is I can distribute it, right? So I can say 3 times x, distribute my plus sign, 3 times 5, 15, and I get 3x plus 15. So I actually just simplified this expression into this expression. We prefer expressions like this, taking away the parentheses, because parentheses, again, like we saw with previous examples and exponents and things like that, parentheses can be really confusing, and they increase the chances of error. So it's best to distribute and get rid of those parentheses, because this is a lot simpler when it comes, this comes really important if you're like an architect or an engineer, things like that. You want to make your problems as simple as possible. So when you're actually putting in calculations for like, okay, I'm building a building, I need to know weight limit, I need to know like the load of these beams and all this kind of stuff, right? You're using a lot of formulas. You want to make those formulas as simple as possible so that when you plug in your values into a calculator or into the computer or whatever, there's less likely you're going to have an error in your calculations. When you have lots of parentheses in there, there's a chance you're going to miss putting a parentheses, you're going to forget it, and remember, missing parentheses can change the whole math problem, right? So we like to simplify to a form that does not have parentheses anymore. Just get rid of them. It makes it complicated, makes it more likely that you will have errors in your calculation, and that can be really deadly as an engineer, as an architect, because that could mean your whole building falling down when there's just one too many people that you thought you calculated for and you didn't, right? This is why they have max capacities in rooms. It's accounting for things like weight limit, all that kind of stuff, right? And elevators, and that depends on really accurate math, right? So then, yeah, so we use distribution because, again, we can't do PEMDAS because we don't know our variables. So you're going to be using distribution a lot from now on. It's just something going to get used to. It's going to be really common. If you do Algebra 2, then you're going to be doing a lot of distribution and factoring, all that stuff for fractions, right? It gets really complex. Okay, so let's just work on examples. So right, so we just say 2 times x would carry over our minus sign, and then 2 times 4 is 8. So hopefully it's pretty simple, right? I just distribute the 2 and multiply by each thing. I don't know what x is, so this is the simplest I can make it. Just 2 times x is just 2x. Right? Until I know what x is and plug it in, this is a perfectly acceptable answer. We're just simplifying your expressions. That's all we're doing. Oh, sorry. 4. Right, this is where PEMDAS again comes into play. So parentheses, we can't because I don't know what x is. Okay, and there's no exponents, but I can distribute. This is multiplication, right? So 4 times x, carry down my plus sign. 4 times 7 is 28. And distribution, really important to remember, only distribute within the parentheses. Okay, so you notice I don't distribute my 4 to this 21. The 21 is outside of the parentheses. I'm saying 4 times x plus 7 in parentheses, right? I'm not saying if I wanted to include 21, that would also be in the parentheses, but we're just saying 4 times this in parentheses. Okay, the 21's outside, so I'm just going to carry it down. I can combine this, right? 28 minus 21 will give me 7. So I get 4x plus 7. And as you can see, that this is really complex, but I just simplified it. That's what we're doing with all of these. We're simplifying to 4x plus 7. This is so much simpler, right? If you were going to be building a building and your measurements are going to determine whether this building is going to collapse or not, I would much rather plug my numbers into an equation like this than to an equation like this, because there's a chance that I might forget my parentheses, I plug in my number wrong. You know, there's a lot of just the more buttons you have to press on your calculator, the more likely you can press something wrong, right? Because we're humans, we make mistakes, it's okay, but that's why we simplify. Right, so now you might have something like this. Gonna distribute. Okay, so I distributed my 3. I just wanted to write this one out because I don't want this one to confuse you. This time there's a number in front of our x's, right? It's 4 times x. So if you remember, that's just 3 times 4 times x. So I can just multiply the numbers I know. 3 times 4 is 12. I don't know x. That's totally fine. We're just simplifying right now. 3 times 2 is 6. We get 12x minus 6. Okay, we're going to throw in a negative number. So this is negative 2 times 2x minus 4, right? So I'm going to distribute negative 2, right? So it's just paying attention to those negative signs. Negative 2 times 2x minus, and this is where sometimes I'll like add in a parentheses so I don't confuse the minus with the negative of the 2, times 4. Negative 2 times 2 gives me negative 4, and then times x, right? I don't know what x is, minus negative 2 times 4 is negative 8. And we usually don't write minus negative. Instead, we change it to adding the opposite, right? So we'll change it to adding the opposite. So we get negative 4x plus 8. Okay, so just paying attention, again, those tricky negatives, they suck, but it's just about double checking, triple checking. Right, if you ever want to check your work, it's kind of like a proof. So if you want to check, you're like, is this the, did I do this correctly? I can check, does negative 2 times 2x minus 4 equal to negative 4x plus 8? And then maybe you can pick any value for x, so I'll just make it simple. I'm going to check, let's say x is 1. Do these two equal to each other? You don't have to check. This is just, if you're not sure. Sorry, my 1 got kind of morphed into the line. X is 1, so I say negative 2 times 2 times 1. I just want to check that I simplified it correctly, because remember, we just worked our way from here to here. That means they're the same thing. This is just the simplified version. Okay. So that means they're the same, just one is written in an easier form. So then -2 times 2 minus 4. This is -4 plus 8. -2 times -2. -4 plus 8 is 4. -2 times -2 is 4. 4 equals 4. It checks out, right? So I did a check. It checked out. That means I simplified my problem correctly. So this is the right answer. Again, this is not required unless like a problem tells you check your answer, right? But just if you're ever unsure, you can always check your work by substitution. And you can do it with any number. X equals 2. Just that would mean you're just plugging in 2 into X for each one. You can do it for anything. I always just like to pick it really simple. I just pick X equals 1 to make my math easier. Okay, so just paying attention to those negative numbers. All right, so yeah, you can distribute variables. Okay, so maybe you have X times 2X. Right, because remember, a variable is just a number. You just don't know the number yet. Right, so X times 2X. So that means you can, whatever you can do to a number, you can do to a variable. It doesn't mean you're going to know the final like answer, the final value, but it means you can simplify it. Right, and then X times 4. Okay, if you remember, 2X is just 2 times X. If we look, these two have the same base. There's 2 of them. If it helps, I'll just rewrite it. I'm using the commutative property. I'm going to write this in different order. So 2 times X is 2 times X squared plus 4X. I switched it because you don't really see the exponent first. You usually always put the number first. I find it less confusing that way if you're just consistent with that. Okay, and that's simplified. All right, so that's distribution, and you can see now why it's useful when we're using variables. Before, when I did it with just numbers, it's like, okay, but yeah. And you can see too how when you distribute, it's a lot simpler.